Welcome to 9.2 Systems of Equations in 3 Variables. Today we're going to talk about solving systems or 3 by 3 systems, meaning 3 equations with 3 variables. Our solution will now be an ordered triple, and that ordered triple is going to be in the order X, Y, Z, or in alphabetical order depending on what variables you are given. So let's just jump right straight into our first example here. Okay, if we're going to solve this system, notice we've got 3 equations this time. Now this isn't a true 3 by 3 because not all 3 equations have 3 variables. In fact, we can look at this bottom equation and solve for z right away by dividing both sides by 3. So we get z to be -3. I want you to then plug in to the second equation for z and solve for y, and then use those 2 values for y and z to solve for x. Pause the video right now and see what you get. Hopefully this problem didn't cause many issues. When we plug -3 in for z, remember to use parentheses, and we end up, as we work through it, we get y to be 1. Now we're going to plug in y into our first equation and z into our first equation. Again, use parentheses every time we're making those substitutions. So as we carry out -4 times 1, we just get -4, -3, that's where we get the -7 from, adding 7, and then dividing by 2, we get x to be 2. So now that we have all 3 of our variables, we have to write our solution as an ordered triple in the form x, y, z. So as we do that, we have our solution to be the ordered triple 2, 1, -3. Now we're going to get into some examples of how to solve true 3 by 3 systems. So 3 equations with 3 variables. So after I go through this, I want you to pause the video and make sure you have these steps down. So step 1, we're going to pick 2 equations to combine in order to eliminate 1 variable. Then we're going to pick 2 different equations to combine and eliminate that same variable we did the first time. This will lead us to a 2 by 2 system, which we are very comfortable solving. So we will solve that 2 by 2 system. Then we'll substitute into the original equation to solve for the third variable. Pause the video now and get these steps down. As we begin approaching solving this system of 3 by 3s, where we notice we have 3 equations and they all have 3 variables. So the first thing I want to do is I want to kind of look at all 3 equations and look to see, well, which variable might be the easiest one to eliminate, okay? I also label each equation 1, 2, and 3 so that I know and I can label and organize my work very easily. So the first thing I do is I say, okay, well, looking at these 3, it looks like we could eliminate the z's pretty easily because they all have the leading coefficient of 1 and some have different signs. So I'm first going to take equation 2 and equation 3 and I'm going to rewrite those. And I don't need to manipulate them in any way because my z's are already opposite signs. So when I add these 2 equations together, I end up with 5x. My y's happen to be eliminated as well, and same with my z's. And I end up with 5x equals 10. So this is actually even better because now I can solve for x right away. So when we do that, we're going to get x is equal to 2. So we're going to kind of hold off on this right now, okay? I now am going to take equation 1 with equation 2 and I'm going to try to eliminate z again, okay? Because again, they're both opposite signs with a leading coefficient of 1. So all I have to do is add these 2 equations together. When we do that, I'm going to get 4x minus y. The z's will cancel and we're going to be left with equals -4. Well, what we can do here is we can take this x and plug it into that equation to solve for what y is. So we will go ahead and do that. 4 times our x value of 2 minus y equals 4. So when we go through and we solve, we'll get -y. 4 times 2 is 8. Subtracting 8, we're going to get equals -4. So we'll get y equals positive 4. Now we have two of our equations, so we can go ahead and plug into one of the other equations, it doesn't matter which one, for x and for y, and we will now solve for z. So I plugged into this second equation here. So we'll have 3 times our x value, which is 2, plus our y value, which is 4, plus z equals 9. So 3 times 2 is 6, plus 4 is 10. So that's where we get our 10 plus z equals 9. So subtracting 10, we get z to be -1. So we can state our solution as our ordered triple, 2, 4, -1. This last example, again, is a true 3 by 3. We have 3 equations with 3 variables. So I label 1, 2, 3. I kind of look at all 3 of the equations and I ask myself which one's going to be the easiest to eliminate, and we have to do that twice again. So as I'm looking, I think, well, again, z's are going to be the easiest because they all have the same coefficient already, and all that we have to do is look at their signs. So as I go through, I pick the first 2 equations. All right, equation 1 and equation 2, I rewrite those. I picked those because the signs for z are already opposite. So when we add these together, x plus 2x, I get 3x. 2y plus a -y, I get y. The z's get eliminated, they're gone. And then 1 plus 6, we get 7. So I kind of put this guy off to the side, and we're going to come back to him. Okay, now I need to go and I need to use the third equation, all right? And I have to pick, well, which one's going to be better to use? Well, if I'm eliminating z's, which we have to because I did that the first time, I need to get an equation in terms of x and y again. So with this third equation, I choose 2 to go with it because the z's have opposite signs already, and I don't need to manipulate any of the equations by multiplying by something else. So if I rewrite equation 2 and equation 3, I can go ahead and combine them right away. So when we do that, we're going to get 2x plus 2x is 4x, -y plus -y is -2y. Our z's cancel again, and we have 6 plus 0 is just 6. So we have yet another equation in terms of x and y. So now what we have is a 2 by 2 system of equations. 2 equations with 2 of the same variables. So our next step is to solve this 2 by 2 system for x and y. I want you to pause this video right now, and I want you to solve the system between these 2 equations, and then check back when you're done. So just starting the process, I took this first equation here and multiplied it by 2 so I could eliminate the y's. So when I did that, I got 6x plus 2y equals 14. And now we can combine these 2 equations here. And when we do, we eliminate the y's, and we are left with 10x equals 20. So we're able to get x to be 2. Since x is 2, we can now substitute into one of these blue equations that we have, and we can solve for what y is equal to. So I plugged into this top equation here, 3 times 2 plus y equals 7. So we get y to be 1. So now I have 2 of the 3 variables. In order to solve for z, we need to go back to one of the original equations and substitute back in. So I just chose this top equation to plug in x and to plug in y so I could solve for z. So we end up with 2 plus 2, so 4, minus z equals 1. So I subtract 4, I get negative z equals -3, so then z equals +3. Writing my answer as an ordered triple, we get the solution 2, 1, 3. We will certainly go through more of these as a class next time we see each other. If you have questions, let me know.